Hello everyone, I am Abhishek Kumar Chaudhary, Senior Lecturer Physics, Gosala, Sri Chaitanya. Today's topic in the series of NEET revision, we have conservation of angular momentum and rotational kinetic energy. This topic is related to some other topic also. It is a continuation topic, we can say. Like if you want to know conservation of angular momentum, what we should know it, first what is angular momentum and then what is torque, what torque does. Torque concept, torque knowledge is basic knowledge I am saying is very important for this topic. Moreover, what is angular momentum also. So I am telling this topic particularly, and the point is some basic formula, some basic knowledge and some basic understanding. See, this topic, rotational dynamics overall, is conceptual understanding topic. As far as NEET is concerned, questions will be not that much difficult, but tricky questions will always be there. So for those tricky questions, conceptual knowledge is very important. Conservation of angular momentum. See, first I will write angular momentum L R cross mv, that is the orbital angular momentum. That is magnitude wise can be written as momentum into perpendicular distance, or we can write m into r into v perpendicular, means perpendicular momentum into r. This is in magnitude, and r cross mv in vector form, where we can write r as ijk form and v can ijk form. Then we have to take spin angular momentum. Spin angular momentum we are taking. Spin angular momentum is I into omega. Okay. I will be obviously moment of inertia, and that moment of inertia will be about the axis of rotation. Like suppose we are discussing angular momentum with respect to center of mass, and velocity is also at center of mass. So velocity and point of rotation both are at the same point. Like what I am saying, this is a rigid body, here is center of mass and velocity is given for center of mass, then to r will be 0 because r is from point of rotation to point of velocity. Here point of rotation is center of mass and point of velocity is also center of mass, so r will be 0. Then orbital angular momentum will not work, then it will be only spin. Otherwise, a rigid body can have both L orbital, L spin, and according to their direction, vector quantity, direction is important. According to the direction, we will add up the resultant. Sometimes opposite direction will be subtracted also, vector addition will be there. Then, how this is related to torque? Newton's second law of rotation. Quick revision points are this: Newton's second law of rotation. If I am writing this Newton's second law of rotation, then that will be change in angular momentum dl by dt, and that will be equal to external torque. Okay. If no external torque is there, that's why it is important that we have to know that what makes external torque 0. That is the continuation topic. External torque 0, then we have to know obviously what is torque all about. When external torque is 0, then dl by dt is 0. It means there is no rate of change in angular momentum, and derivative is 0 for constant quantities. So that condition will be L equal to conserved or constant. What is the topic here? Conservation of angular momentum. It starts when external torque is 0. Means you have to practice it, but some basic situation I can tell you. Suppose some rigid body is expanding and shrinking. You can take it like Earth is shrinking or expanding. Most of the cases that is angular momentum conservation question. Or when some rigid body is there and some particle is striking with it, collision is there, and after collision motion becomes rotational. Like this is the pen and I am striking here, and after striking the motion is rotational. In also most of the situation here, after collision rotation, that is the conservation of angular momentum question. There are many if and but there, but you can develop this kind of thought process. What situation, like I told you two situations here, is some body moment of inertia is changing but external torque is not there. So all these situations will be conservation of angular momentum. Okay, so angular momentum will be conserved when external torque is 0. Here we can write Li equal to Lf. Then third point, one more quantity you can see here, rotational kinetic energy. Rotational kinetic energy, this rotational motion is there for a rigid body. So rigid body has to be there, and for that rotational kinetic energy, that will be half moment of inertia omega square, half I omega square. Then rotational kinetic energy can also be written as K equal to half I omega into omega. And what we have discussed already, I omega as angular momentum. So here I can write this we can write that omega is equal to 2k by L, where L is what? L is angular momentum. 2 kinetic energy of this can be a formula where you can see three quantities we are relating: angular velocity, rotational kinetic energy, and angular momentum. And one more formula, do revise on that. Many questions are being asked and already been asked. If you'll see PYQs, you will get it. That is like in Newton's second law, we write P square by 2m, that is kinetic energy. That is translational kinetic energy. If I am going to rotational kinetic energy, P will be replaced by L, M will be replaced by I, and that is the rotational kinetic energy. So these are the basic formula I would suggest you to go through, and some situation also that I already told, shrinking questions or expanding questions or after collision rotational questions. On these kind of questions, we can expect the angular momentum conservation. We have to write the earlier angular momentum, final angular momentum, equating it, and whatever is required can be get from there. Okay, so on these questions basis, let's see what some questions NEET has asked, some other kind of questions also, just to practice and do develop a pattern while solving questions on this particular topic, what is coming, what is happening, and that pattern will help you. It will always strike what to do. Okay, looking at the first question. Read question properly first. If the earth were to suddenly contract, as we have discussed, expansion, contraction, most of the case for a rigid body, that is the question of angular momentum conservation. So, if the earth were to suddenly contract to 1 by nth of its present radius, so that is your initial earth, let's say radius is r, and then a new earth, and basically not a new earth, in this question we have to take contracted earth, that will be equal to radius r by n. But again, question is saying without any change in mass. Mass is here, mass is here. You can take two spheres here whose masses are equal and radii are different. So what is the moment of inertia in the first case? 2 by 5 mr square. What is the moment of inertia in the second case? 2 by 5 m r square by n square. These are two different moments of inertia. What we have to keep in mind, angular momentum conserved in contraction. No external torque is acting. No one from externally making it to contract, right? It is contracting on its own. All internal torque, internal forces are working over there. So angular momentum is constant. It means whatever is I1 omega 1 in the first case, that is I2 omega 2 in the second case. Or omega is 2 pi by t. Why I am saying 2 pi by t? My question is asking me time period. See, duration of the day, that is the time period. In that case, what we can write? I1 2 by 5m, 2 by 5m constant. R square is also constant. So first case I am writing I1. I1 is, let's say, 2 by 5 m r square, and omega 1 is 2 pi by t1. Initial time was 24 hours. Then secondly we can write 2 by 5 mr square, and then n square also, because r becomes r by n, and then 2 pi by new time that I have to find. 2 by 5 mr square, 2 by 5 mr square, 2 pi cancelled, and new time is 24 by n square. That is 24 by n square. C option is the correct option. Okay, question is very simple. L1 equal to L2, I1 omega 1 equal to I2 omega 2. Why I am picking I1 omega 1? Because time period is related to omega. So I have to express in terms of omega, right? But before that, why L1 equal to L2? That should be clear. So make it a habit. Contracting question, expansion question of rigid body. In general, you can develop a pattern. I will have to do angular momentum conservation. Okay, moving to the next one. If rotational kinetic energy of a body, is increased by 300%. In these kind of questions, see, word plays there. Increased to 300%. That is 3 times. Increased by 300%. That is 4 times. So I have initial kinetic energy K. Then I have final kinetic energy 4K, which is increased by 300%. Then the percentage increase in angular momentum. Simply, you have, if the rotational kinetic energy of a body, one body is there, moment of inertia will not change. We are not changing anything in the body. So I will do this question by keeping I constant. So L is there, K is there, I is there. What is the relation between them? L square by 2I is equal to kinetic energy, right? I is constant, so kinetic energy is proportional to L square, because this inertia portion we are taking as constant. So I am writing ratio K by 4K, initial kinetic to final kinetic, that is initial angular momentum to final angular momentum square. It means final angular momentum is 4 times L square, final angular momentum is 2L. So if final angular momentum is double, so increase to 200, but by 100, because change is only L only, no? So what is the change? L dash minus L by L into 100, that is 2L minus L by L into 100, and that will be 100%. So question is asking angular momentum will be increase in angular momentum, not final angular momentum, only the increased portion, that will be 100%. Got this? Again, see how we are doing the question. We are looking in the question, picking the quantity, rotational kinetic energy, L, I, how they are related, and on that pattern. This kind of pattern you have to develop to practice these kind of questions. So let's move to the next one. This question. What primary task? Reading question is an art. Reading question is very, very important for NEET. A particle of mass m is projected with velocity. Now in this question, omega is not there. It's velocity. Velocity V means, prima facie I am developing this question in my mind. It is a orbital angular momentum type of question. R cross mv or mv are perpendicular. Because velocity is given, omega is not there. I'll see further what is there. So it means there is a quantity, x-axis velocity is A and y-axis velocity j cap is B. Okay, from ground. Let's say this is origin. The angular momentum of particle about point of projection means about O when particle is at topmost point. Kind of a projectile question, isn't it? Projectile question, x component is there, y component is there, it will move like this and particle is at highest point. At the highest point, we all are aware in projectile concept, horizontal velocity will not change, no acceleration is there, no. Motion, projectile is also motion under gravity, not 1D, 2D is there, velocity is in different line, but as far as force is concerned, that is the only gravity, and gravity is along y-axis. So x-axis, neither there is a force nor there is an acceleration and no change in velocity. So velocity earlier was A, so this is also A. A is velocity, and if I will multiply with mass, that will become momentum. But angular momentum, when linear velocity given, that is mv into r perpendicular. R is always from point of rotation to point of velocity. Point of rotation to point of velocity. But this is R, and what we need is R perpendicular. So if I will take its perpendicular component, that will be maximum height. So my angular momentum, my answer of the question will be M A H max. H max is y component of velocity, that is b square by 2g. That is maximum height. uy square or u square sine square theta, that u sine theta is y component. Y component here is b. That b is your u sine theta if you are taking velocity as u. So I will go for this. M A b square by 2g, M A b square by 2g. Moreover, in this question, only magnitude is asked. Sometimes question might come with magnitude and direction, and sometimes question might come with only direction. So direction of a vector quantity is as important as magnitude. So in this particular question, if we talk about direction, direction is what? Formula is what? Formula is R cross mv. Cross product is the rotational effect, R cross mv. Now, there are many ways of direction, right? You have to develop one way and practice that way in every question to develop the accuracy. Like suppose I am saying R is what? R is this. That R will have a component x and y. I can say xi cap plus yj cap is R. And then velocity here is only along I cap. M, A, and that is x component. So I cross I will be 0. J cross I will be minus k. So direction will be minus k. And minus k means inward. That is one pattern. Secondly, you can take R cross mv if I am taking this R forward. Because both vectors should have same point co-initial before you check for cross product. Or any mathematical addition, subtraction. Two vectors must join at the tail. So R is there, V is here. R cross V coming inside only. Make them co-initial, R cross V coming inside. That way also we can check the direction. So direction either IJK or R cross V, but direction is as important as magnitude. So don't think that your question is complete because only question is asking magnitude. But maybe in NEET they will ask direction also. So practice with both. Even if some question you are doing, only magnitude or only direction is there, you calculate both. That way a student must practice. Okay. See the next question. That is a theory type question. In recent NEET, very important theoretical questions are making quite an impact there. Which of the following statement is incorrect? Incorrect. So we will tick the option that we feel like is wrong. Kinetic energy of point mass. As I saw the point mass, my mind is full with translatory motion because point mass cannot rotate. Revolve they can do. Circular motion they can be, but circular motion is also translatory. The pure rotation is not possible. So point mass, translatory kinetic energy is half mv square. It is correct. I will not tick because incorrect will be ticked. That is, we feel like wrong. So this is correct answer. The rigid body, rotation, translation, both rolling motion we used to study there, translation is possible, rotation is possible, so both are possible. But when a rigid body is in translatory motion, half mv square, correct only. Rigid body rotatory motion, half I omega square, correct only. Kinetic energy of a point mass revolving means circular motion about an axis is half I omega square. See circular motion, that is the particle moving with some velocity v. In circular motion, that v will be r omega. If I am writing half mv square, this is half mv square, I am writing this as half m and v value, let's put r square omega square. For this particle from center axis, moment of inertia is this and then omega square will be there. So that will be half I omega square. It means both are same. If you are writing half mv square for revolving particle or you are writing half I omega square, both are pretty same, exactly same. But question is saying it is different. What I found same. My option is saying different, means this is wrong. And incorrect me, we have to talk wrong one. So that we will go with it. D option is the wrong option. In theoretical question, analyze it well. Don't jump onto any of the option before you have read all the options clearly. Read all the options. Even if you're sure about A and B, make it a habit of reading all the options. It will save you in many of the questions from negative marking. Okay. Moving to the next one. A particle performs uniform circular motion. This is a revolving motion, translatory motion with an angular momentum L. One thing are you noticing, the angular momentum is not there for only pure rotation. It is for translatory motion also. I'm not saying rectilinear, translatory motion also, because it depends on momentum's arm length, momentum and perpendicular distance. So momentum can be in translatory motion. If perpendicular distance is defined, angular momentum is there. For electron also we study orbital angular momentum for orbital motion, then spin angular momentum. So that orbital angular momentum is the part of translatory motion. So here angular momentum will be very much there if the frequency of particle motion is doubled. So F is becoming 2F, means omega is becoming 2 omega. Okay. And kinetic energy is halved. Kinetic energy is becoming k by 2. Then what is angular momentum? Okay. We have done a formula for this. Let me write it again for you. What was this? Kinetic energy is half I omega square, half I omega into omega. This I omega is L that question is asking. So I would write this I omega L equal to twice of kinetic energy divided by omega. Now L dash, final L, according to our question, what is happening to kinetic energy? Half 2 into K kinetic energy by 2. But 2 will be there in every kinetic energy, omega equal to twice of kinetic energy by angular momentum, or angular momentum is twice of kinetic energy by omega. So this is 2K, kinetic energy is K by 2, okay, and omega is becoming 2 omega, that will be 2 omega. But this 2K by omega, that was your initial L. 2K by omega was initial L. So if this 2K by omega, initial L, what is coming in denominator? 4. So L dash will be equal to L by 4. This is an important formula that relates three physical quantities. One is angular momentum, one is kinetic energy, and one is angular frequency or frequency. Okay, 2 pi f you will write, that will become frequency also there. So what is the point? Remember this formula L, K, omega relation. Sometimes this can directly solve the questions. Okay, got it. So what you're filling with the question solving? Mainly formula based, sometimes little conceptual discussion there. Let's see the next one. Particle of mass m moving with the constant velocity. When I'm doing angular momentum question, as a student we are doing it, our mind should read one thing very properly. It is orbital angular momentum question, spin angular momentum question, or both. Means I will go with MVR perpendicular or R cross MV, same thing, or I will go with I omega, or I will go with both. In this question, angular momentum is there, but when I look at the diagram, in diagram what is there? Arrow wise, means it is linear translatory motion, velocity is like this. So in velocity is like this, then I will keep in my mind that I will go with MVR, not I omega. Now angular momentum about O, it is clear I have to use MVR, is 0 when it is at A. Particle is at A point. Where is the particle? Particle is at A point. At A point your mass is there. This is mass m which is at A. Velocity, let's say this arrow is velocity, so we have the momentum also, mv. But mv is not sufficient. No, mv needs to have a perpendicular distance also. From where? Again this perpendicular distance, write 2-3 times the distance from where? From velocity point to application, the point of rotation to point of velocity. These 2 points will have a perpendicular distance. But here, velocity point and this, they are having no distance with each other. There is no perpendicular. They are in the same line. So r is not 0, rather r perpendicular is 0. Hence theta is 0 and r perpendicular is r sine theta. So r sine 0 degree, that will be 0 only, no? So r perpendicular is 0, so angular momentum has to be 0. So it is 0. It means this is a right one, but question is asking not correct. So I will tick that option that I feel like wrong. Second one, same at all points along the line DE. What will decide it is same or not? M, V, R perpendicular. M is same, V is same, R perpendicular is also same, then it will be same. So in the line DE, at every point distance will change, but I am not interested in distance. What we are interested in the perpendicular distance, that is 1 meter. So MV is not changing, as well as D to E perpendicular distance is also not changing. So it will have the same value everywhere, and option is also saying the same. It means it is not incorrect here also. Now read the third one. See, theory question, I will go up to the D option, then I will decide. Of the same magnitude but opposite directed at B and D. Okay, B and D. Pick the point B and D. And when we are picking the point B and D, then we will see at B and D directions are opposite or not. Okay, B and D directions are opposite or not. Let's have a look. Where is B? D. Now in this question, direction became important. No, that we were talking also. The angular momentum or any vector quantity have a proper knowledge about direction as well as velocity. It's a very simple one. For B point from origin, your R is x-axis, R is I cap, and your momentum, see the arrow, that is along y-axis. So momentum is J, velocity is along J. R cross MV means I cross J, and here at B, I cross J, that will give us K cap, that we are talking at B point. Now the same I will discuss at D. At D, from O, the R is here, R is proportional to J cap, but D is, velocity is, momentum is along x-axis, so velocity proportional to I cap, R cross V, J cross I, that will be minus K cap. Obviously direction is K and minus K, they are opposite, but magnitude will be same because R perpendicular has the same length, 1 meter and 1 meter. It means magnitude same, direction opposite, that is also correct. Going to the fourth one, fourth is saying increases at it moves along the line BC. Increases means magnitude wise, right? BC momentum is MV and perpendicular distance is 1. So when perpendicular distance not changing, remain 1. Magnitude of momentum not changing, how can it increase? So it is not increasing. It means that is incorrect. We will go with the D option. This is incorrect. So that is the point here that we will go with. So that question was solely based on direction. So direction you can do with that way also. R cross MV is here and R cross MV is inside. See, I will make them co-initial. R cross MV outward and here co-initial R cross MV inward. So whatever you practice, IJ or inward, outward, screw rule, thumb rule, whatever you do it, but do one thing precisely in every question. That will give you a very accurate habit of it. Okay, moving to the next question. Have a look. Uniform thin circular ring of mass m, radius r is rotating about a fixed axis. Identify the rigid body, that is a ring. There is a fixed axis, constant angular velocity. Okay, constant angular velocity, it is rotating. That is given. It will have some angular momentum. Let's write it. That is I for ring is mr square into omega. Now we are making some change. What are the changes? Two objects, each of mass m, two objects, each of mass m are attached gently, means no external impulse we are given. We are just putting it, but it is not making change to the motion just that time. In due course of time it will do it, but we are not imparting some impulse to it, gently placed. And where are we placing? Opposite ends of diameter. Here is 1 m, here is 1 m, and obviously opposite end of diameter, so that will be from axis, RR will be the distance. The two rings now rotate. Have we changed something to change the rotation? Yes. We have changed the moment of inertia without any external torque, without any external impulse, because we are gently putting it. So now final angular momentum is mr square inertia, that was so very much there, plus small mr square, that is 2 mr square, and since moment of inertia changed, omega will also change. We will equate these two, r square will be cancelled, m omega should be in numerator, m omega, and denominator will be m plus 2m, m omega, m plus 2m, that will be your answer. Got this? Simple. Inertia changed, gently placing was the important key there. If you're giving some impulse, then angular momentum will change. Gentle, no impulse, angular momentum is conserved. That was the question about. Hope you understood this. This kind of question you can expect in NEET. Important model. See the next one. Two rotating bodies, A and B, mass m and 2m, with moment of inertia IA and IB. Okay, so moment of inertia and their comparison is given. IB is greater than IA, and they are rotating bodies. Equal kinetic energy. Now Ka is equal to Kb. That is also given. These two information are given information. That is your NEET 16 question. LA, LB, angular momentum comparison. Straight away, what is question? Li and K relation. What is the relation? L square by 2I is equal to K. But K, you can see, question has mentioned the same, it's a constant. K is constant, means L square is proportional to I. L square is proportional to I. Now if, see, IB is greater, then LB will be greater, no. LB will be greater than LA. LB will be greater than LA. Exact value will come in root, no option is in root. That's why I will go with, it is proportional to I. L is greater, IB is greater, then also LB is greater. If A moment of inertia will be more, then A angular momentum will be, but this is not the universal fact. It is happening because here question is saying that kinetic energy is constant. If the same question says that I is constant, then L will depending on K. If same question says that L is constant, then K inversely proportional to I. Three physical quantities are there. Any one will be constant and proportionality of two other will be discussed. That is one very common question model that NEET asks. Next one, it is also previous year NEET question. Have a look on the question. Two disks of same moment of inertia. So we have two disks in the question. And according to given information, their moment of inertia are same. Regular axis, let's say geometric axis, they are rotating about their geometric axis. Like this they are rotating. Omega 1, omega 2 are angular velocity. They are brought into contact face to face coinciding the axis of rotation. Means this is putting here and they are touching each other. The expression for loss of energy. Okay, understand the question. That is an axis, or let's say this is axis. Here one disk is rotating. Second disk that was rotating earlier, but it is made to touch it. Here one thing is very important and very conceptual also. We will assume this disk to be rough. Friction is there. What friction? Because one disk is rotating, second is also rotating with different omega. So when these two disks will touch each other, at the touching point, there will be relative motion with respect to each other. Relative motion. Relative motion will be, friction will be opposing it. So one who was having more omega, higher omega, that will be retarded by the torque of friction. And one that was having lesser omega, that will be accelerated by the torque of friction. And after some time, they will have common omega. When common omega is there, loss in kinetic energy is there. But if question will deliberately write that both disks are smooth, there is no friction, there is no agent there who will change their omega. There is no work being done to change omega. Who is the agent? No force is there. In that way, omega will not change, kinetic energy will not change, the change will be zero. So friction has to be there. So be alert if the similar question comes with a smooth disk. Then there is no friction and no change in kinetic energy will be there. Omega will not change. Okay. But since 0 is not the option, so we will take that friction is there and loss in kinetic energy is taking place. In that we will use the formula of loss in kinetic energy in case of common omega, that is half I1 I2 upon I1 plus I2 into omega 1 minus omega 2 square. In this omega 1 minus omega 2 square, here is this, here is this, here is this. This is rolled out completely. They are moving in same direction or opposite direction, not given, so I will not go with this. And moreover, I is same, so that would be, students, I into I square, I plus I plus I 2I, and that is omega 1 minus omega 2 square. This is equal to I by 4 omega 1 minus omega 2 square. That way we will go with this option. Okay. So what formula in losses? Try to understand. This is just like inelastic collision question. There it was with linear velocity. Here it is with angular velocity. Important point, friction is must. If this question will have 0 option, question becomes more interesting. Then we will have to see if friction is there or not there. One word smooth will change the question entirely. So summary of this question: one rotating disk makes contact with other. Friction is there. At every contact point there is a relative motion. That relative motion is opposed by friction over there. The higher omega will be retarded by the torque of friction and the lower omega will be accelerated with the torque of friction. They will have common omega, and then loss in kinetic energy will be there, whose expression goes with like this. I will put the value of I and I will go with the question. That was the answer of this question. Moving to the next one. See this. This is also previous year NEET question. I hope you are developing a pattern for solving questions. Concept in rotational mechanics is very, very important, but concept is not something which is not achievable. Concept is the very much right thing. What is the fact? What is the actual thing? No presumptions in the question. Whatever laws are there, those we have to put precisely, rightly, we will get our answer. In this question, the solid sphere of mass m and radius r, rigid body is there. So it will have a spinning motion. Solid sphere has a mass of m, the radius is r, and it is rotating. Spin angular momentum, orbital is mvr is not there, I guess. Let's see the question. Diameter. One thing I want to tell you guys for moment of inertia also, sphere geometric axis is the axis of diameter. So diameter doesn't make a change to sphere moment of inertia. It does make that change in disk and ring. There it becomes half. So don't do that mistake. In sphere, if it is written moment of inertia about diameter, the diameter is the actual geometric axis. It is not like the sphere and ring. So use the actual moment of inertia, don't half it. Okay. So here moment of inertia will be 2 by 5 mr square, rotating about its diameter. Solid cylinder is there, same mass, same radius, and rotating about. This is for sphere. Right, for cylinder, its moment of inertia, solid cylinder is there, mr square by 2, because mass and radius are same. Same about the geometric axis with an angular speed twice that of sphere. Now here angular speed is doubled. Ratio of kinetic energy. So what is this? Simple. Kinetic energy of rotation is sphere by cylinder. Kinetic energy of sphere, kinetic energy of cylinder. What is kinetic energy of sphere? Half. I'm not writing, that will be cancelled. I. What is I? 2 by 5 mr square and omega square. Then here mr square by 2. Mr square by 2. And mr square by 2, after that you have to check this, its angular speed is twice that of sphere. It means 4 omega square. And you will write 4 omega square, then it will be mr square, okay. that 2, 2, 2, 4 by 4 cancel, this is cancelled, and option will be 1:5. Only thing proper take care that we have to take is what is I, about what axis is I, and what is omega. In sphere, you can do that mistake if you're thinking, if you're using the concept of ring and disk, ki I diameter is half, then you will write 2 by 5 divided by 2, 1 by 5, and then the answer might change. That you don't have to do. So simple question is there, NEET question. What we have to develop a pattern here: kinetic energy, angular momentum, moment of inertia, angular velocity. These 4 quantities, how they are related. Every permutation and combination could be one question in NEET. Moment of inertia again has a huge concept. What parallel axis, perpendicular axis, all you have to know it. Then torque zero, gently push, or what you are giving impulse. Torque concept is very, very important. So it is not an isolated topic. Many supplementary topics are also there. But continuation topic, only this rotational and conservation, these kind of questions you should practice the formula based questions much to get precise answer in NEET. Okay. So that was our discussion for this topic. I hope you will again develop a pattern, solve this question, be good with the formula. God bless. All the best for NEET.